My name is Abiodun Hanifo. Today I'm going to briefly talk to you about nomenclature in organic chemistry. In organic chemistry, we have different classes of compounds with different functional groups and different names. So it is important that we have naming convention for naming all these compounds. So today I'm going to show you how we can identify what we call parent names and functional groups in different compounds, and how we prioritize on which functional groups becomes the parent name of the compound. So I'm going to show you a few examples, and we're going to use this naming convention to name these examples of compounds, and we're going to appreciate the IUPAC naming priorities to identify which functional groups go into the goes to become the parent name of the structure that we're going to be looking at. And you can apply this to name any organic compound in organic chemistry. So we're going to take a look at the first thing we're going to take a look at is the IUPAC naming priorities. So IUPAC naming priorities. So in organic chemistry, like I said earlier, we have different functional groups. And as you can see here, I've listed some functional groups in organic chemistry, or let me say the major functional groups in organic chemistry. As you can see here, we have the carboxylic acid, we have ester, we have acid, chloride, amide, nitrile, halides, ketone, alcohol, amine. We have the alkene, alkyne, alkane, esters, halides, and the nitrile groups. So these are what I would say what I would call the basic functional groups in organic chemistry, and some of these are actually derivatives of this one here. So the ester, acid, chloride, and halides are all derivatives of carboxylic acid, and we have nitrile and the rest. So the first thing I'd like to show you is that because in organic molecules we can have different functional groups. We can have two or more of these functional groups in one single molecule, and so it becomes imperative to decide which one of the functional groups go into the parent name. So let's quickly take a look at this example. So let's say we have something like this, very simple structure. Now, this is an organic molecule, and we are trying to name this compound. How do we name this compound? Now, the first thing you need to identify are the functional groups that are present in this molecule. Now, if you look at this molecule, you quickly see that we have the alcohol, the OH group, and we have the carbon-to-carbon straight carbon-to-carbon chain in this molecule, basically. So in this molecule, there is no double bond, there is no triple bond. So this molecule is basically an alkyl with the functional group that is there. So we have alkyl groups and the functional group. So it's basically a derivative of alkane, basically. So you have OH and you have alkyl chain. So you have something like this in this molecule. So this is basically an alcohol. It's a simple molecule, and what I'm trying to show you here is that this OH group, if you look at it very well, you see that we have two, we can look at it this way. We have two major functional groups. We have the alkane functional group because it is unsaturated. This molecule is unsaturated. It is saturated. This molecule is saturated because you don't have any double bond or triple bond. It is saturated, and the saturation puts it in this functional group, the Arcane family. And also the presence of OH put it in this family, the alcohol family. So basically you identify the parent's name by including the major functional group in the parent name. And the major functional group in this one is, so you have two functional groups, you have the alcohol and the alkane. So according to the IUPAC naming priority, alcohol will be the priority in this molecule. it will be the priority in this molecule. We're going to prioritize on alcohol, and so this molecule is going to be an alcohol. It's not going to be an alkane. It's going to be an alcohol. So it's going to be 1, 2, 3, 4, 5, 6. So it's going to be, so this is going to be a substituent. You're going to see more of this, why this is a substituent later on. So this is alcohol. So this is 1, 2, 3. So this is going to be 1, 2, 3, 4, 5, 6. So that is hexanol, and that is hexantriol, and that is 1, 2, 3, 4, 4-methyl. So this compound is 4-methyl hexantriol, and the reason why it is 4-methyl is this. So this methyl is a substituent. It's a substituent because it is not in the straight chain. The parent name has a straight chain. I mean, the parent structure is a straight chain. So the straight chain has to be the longest carbon to carbon chain, and in this case it is 1, 2, 3, 4, 5, 6. So we cannot say 1, 2, 3, 4, 5 because this is 5. 5 is smaller than 6, and so it's going to be 1, 2, 3, 4, 5, 6. If we look at it this way as well, it's going to be 1, 2, 3, 4, 5, 6, and then we could also branch this way to consider this side, and it's going to be 1, 2, 3, 4, and then this is still smaller than 6. So the longest carbon to carbon chain will be this chain. And so since we are saying this compound has to be an alcohol, the OH has to take priority. So that means that this OH, we have to locate it. We have to assign a number to this OH, and the number that we're going to assign to this OH must be the smallest number possible. So that means that if we try to name this compound this way, where on this carbon to carbon chain are we going to place this OH? It's going to be on the 3rd carbon atom. If we go this way, it's going to be on the 4th carbon atom. And according to IUPAC, the locants of this functional group has to be the smallest number possible. And so that's why it's going to be hexantriol. The X comes from the fact that we have 6 carbon atoms in this parent structure. And this methyl group is because, the 4-methyl is because the methyl group is on the 4th carbon atom coming from this side. And that's why we have 4-methyl hexantriol. You can also write this as, you can still write it as 4-methyl 4-hexanol.
I meant to say 4-methyl 3-hexanol.
So I'm going to quickly show you something, because I need you to understand why we have hexanol here. Why we have X here for 6. So it is important that you understand how we name alkane first before we dive into different compound, different structures that we are going to name. So I'm going to quickly write list the 10 common alkane compounds that we are going to be using to appreciate the different compounds in organic chemistry that we might be coming across in this lecture. So one of the family of organic compounds that is popular that we probably should know about is the Arcane family. So Arcane family, the first 10 members are the methane, ethane, propane, butane, pentane, hexane, heptane. I'm going to write the next one here: octane, nonane, and decane. So it's easy. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what this means is that if we have an alkane compound with 3 carbon atoms, that alkane is going to bear the name propane. If we have an alkane compound with 6 carbon atoms, that alkane is going to be hexane. And the same thing applies to alkene and alkyne. So we have the ethene, propane, butane, pentane for the alkane family, and in a like manner we have the ethine, propine, butane, pentane, and so on and so forth for the alkyne family. And so I'm going to show you another thing. So the general formula for alkane, that should be CnH2n plus 2. So one thing is very common in organic molecule, and that thing is a functional group that we have basically classified as HAR. And you see the HAR everywhere in all of in these structures that I put down on the board here, and it is known as alkyl group. An alkyl group is basically an alkane that is deprived of one hydrogen atom. So if you want to get the alkyl group of the methane, it's going to be methyl. And the alkyl group for the ethane is going to be ethyl. So we say this is the formula for alkane. And in a like manner for alkyl, the formula is CnH2n plus 1. So what that means is that if you want to have the 5th member of the alkyl group, it's going to be pentyl. Oh God, I'm trying not to clean some things off the board. So it's going to be pentyl. And pentyl, that means pent, that is 5. So that is going to be C5H2 times 5 plus 1. So that gives us C5H11. So that's going to be pentyl. So one thing that we often do in naming organic compounds is that, sometimes when we have identified a functional group, then we identify the alkyl group that is present in the molecule, and then we merge both the alkyl group and the functional group together to have the entire name of that compound. So a good example would be something like this. A good example would be something like this. So in this molecule, this is a very small molecule. The functional groups that are present in this molecule, I would say, is alkane. If you don't have any unsaturation, things like double bond or triple bond in a molecule, in an organic molecule, then you know that that molecule is saturated. If you have double bond or triple bond, then it becomes unsaturated. So in this case, we have two functional groups, the alkyl group and the amino group. So in this case, we have the amino group and the alkyl group, and that becomes the parent name for this compound becomes it's an amine basically. So when you have NH2 in an organic molecule, then that compound becomes amine. As long as you only have the NH2 in the molecule with an alkyl group. But in a situation whereby you have other functional groups that has more priority, that has higher priority than amine in the IUPAC naming priority, then you have to look at the priority to determine what functional group would go into the parent name. So just like in this case, since we only have amine as the higher priority here, so this is simply an isopropyl amine. So this is an isopropyl amine. Isopropyl because this is 3-carbon alkyl group, and 3-carbon alkyl group is propyl. But then in this case, we have the functional group amine, the amino functional group attached to the propyl on the 2nd carbon atom, and that makes it an isopropyl. It's an isopropyl in this case, and then it's going to be isopropyl amine. But if it were to be attached to the terminal carbon in the propyl group, it's going to just be propylamine. So it's as simple as that. But then, in appreciation of this, I've actually listed all these functional groups in order of the IUPAC naming priorities. And what that means is that this has the highest priority, followed by this, followed by this, followed by this, followed by this, and this, and this, then this, and this, and this, and number 11, 12, 13, 14, yeah, and 15. So in other words, what I'm trying to say here is that if you have any combination of these functional groups in an organic molecule, you have to remember the fact that a carboxylic acid group in a molecule, in the same molecule with a nitrile, we have higher priority than nitrile. That means that the parent name for that compound is going to be carboxylic acid, and then the nitrile will become a substituent. So if you have nitrile and aldehyde together in a molecule, the parent name is going to be a nitrile, or you say cyano. This is a cyano group or cyanide. It's a cyano if it is coming as a substituent. It is cyanide if you are considering it as a parent name. So just like we said, if we have nitrile and this together in a molecule, so this is not going to be called nitrile. It's going to be in cyano. It's going to be cyano wherever carboxylic acid. And if we have this and this together in a molecule, the molecule is going to be a nitrile because this is having higher priority than an aldehyde in the IUPAC naming convention. So in another word, what we'll say is that carboxylic acid has higher priority than an ester, and this has higher priority than acid chloride. This has higher priority than an amide. This has higher priority than a nitrile. This has higher priority than aldehyde, and this is a ketone. Aldehyde has higher priority than a ketone. A ketone has higher priority than an alcohol. An alcohol has higher priority than an amine. Amine has higher priority than an alkane group. Alkane has higher priority than alkyne, and this has higher priority than alkane, and alkane has higher priority than ethers, and ethers has higher priority than halides. And that is why, in most cases, when you have halogens in organic molecules, you often see them as halo whatever. So assuming you have something like, let's say you have something like this. Excuse me. So let's say you have something like this, another simple molecule. Let's say you have something like this. So this is a very simple molecule, and if I just look at it, I can tell that this is just 2-chloropentane, because it's 1, 2, 3, 4, 5 carbon atoms. That is the longest carbon-to-carbon chain, and you have chloro group as a substituent. And if you look at the chloro group, if you count from here the carbon atom chain, if you count the carbon atom chain from here, it's going to put the chloro group on the 4th carbon. But if you count it from here, it's going to put the chloro group on the 2nd carbon. And in the IUPAC convention, you have to consider the lowest possible number in naming your organic molecule. And so this becomes 2-chloropentane if you go this way, and that is the right way. But if you go this way, it's going to be 4-chloropentane. And we say this is right and this is wrong. And so that's how you name something like that. So another thing is, if you have, let's say we have both the alkene and the alkyne together in a molecule. So let's say we have something like this. So let's say we have something like this. Let me make another carbon. So we have something like this. So this is an alkene, this is an alkyne. So in the priority, we can see that alkene has higher priority than alkyne. And that does not mean that we're going to say this compound is an alkane and then we're going to say this become a substituent. It's not going to be possible. So what we're trying to say for the case of the alkene and the alkyne is that, of course, the parent name is still going to have both the alkene and the alkyne in the nomenclature, but the alkene will come before the alkyne, and it's pretty much because in comes before hine. That is, hine, E comes before Y in the English alphabetical ordering, and so that's why we often prioritize on alkene before alkyne. But then the naming, the way we name it is dependent on which one is the terminal. So we're not going to follow this direction, because if we follow this direction, it's going to put the unsaturated bonds, it's going to let them have big numbers, which we really don't want. We want small number possible. And so we're going to start from this side, and that's going to give us put our alkene in the first position, and then we have this carbon as second, third, fourth, fifth, sixth, seventh. And so this is going to be this is the longest carbon chain, and that means our parent name is going to be a 7-carbon name, and that will be X. And since we have two functional groups that are two unsaturated functional groups, alkene and alkyne, so we're going to say this is going to be one in, but then we have ine also, we have alkyne, so it's going to be 4-ine. So this is one in 4-ine. So actually we're not going to put the E, it's just going to be En. We're going to drop the last E because this is going to have another E. So this compound becomes 1 in 4-ine, and that's what we're saying here, that we prioritize on this, then this. And if we have this alkyne becoming the terminal alkyne, and then this one an internal alkene, we're still going to prioritize on the alkene, but the numbering is going to change. So let's say, for instance, we have something like this. Let's just reverse this thing here. Let's say we have something like this. So this is going to be 1, 2, 3, 4, 5, 6, 7. We are not going to start with alkene, because if we start with alkene, we're going to have it on the 3rd carbon atom. So we're going to start with alkyne here. So it's going to be 1, 2, 3, 4, 5, 6, 7, and that's going to give us, it's going to give us the ine in the 1st position and the in the 4th position. But then we're still going to name this first in the parent name, so that the parent name is still X, but then it's going to be 4 in 1 ine. So that's how you consider naming an organic molecule with both the alkene and the alkyne in the structure at the same time. So that's how we name organic molecules. But that's not all. We have a lot of molecules in organic chemistry, and one thing you just need to know is the naming convention, how you prioritize functional groups, and how you determine the parent name using the priority of the functional groups, and the carbon to carbon chain, the location of the functional group and the substituents, how you identify the longest carbon to carbon chain, and basically those are the things that you need to bear in mind when naming an organic molecule. But I'll quickly, before I stop, I'll quickly like us to appreciate one other example. just before we conclude this class. So the last example I would like us to look at is a compound with, let me see, let me introduce a ketone. So this is another example, and the first thing, like I said earlier, the first thing that you need to do is to identify the functional groups that are present in the molecule. The functional groups first, and then you determine the parent name of the compound in question. So if you take a look at this molecule, you will see that we have an oxo group, but I'll call it a ketone group. So this is a ketone group. It's a ketone group because it is connected to two other carbon atoms. Just as you can see here, a ketone, it's an oxo group that has linkage with two other carbon atoms. And we have a ketone group, and then we have an hydroxyl group. So we have an hydroxyl group and we have a ketone group, and then the rest of the molecule is basically an alkyl group, carbon to carbon chain with no double bond or triple bond. So in this case, we say we have ketone, we have an hydroxyl group, and we have the alkyl group. So if you look at the IUPAC naming convention, the priorities of our functional group or functional groups, you see that where does our ketone lies? It lies here. And then after ketone, we have the alcohol, and which is the hydroxyl group. And then after that, we have, way down here, we have the alkane. So the right thing to do is to give this guy the priority, followed by this, followed by this. So the parent's name in this case can only have one family as the name, bearing the name. So the family that is going to, this compound is going to fall to the family of the ketone, because it's not going to be an alcohol, because the ketone group has more priority, it has higher priority in the IUPAC naming convention than an alcohol. So it's going to be a ketone. And that means that now that we now know that the compound is a ketone family, so we need to identify the longest carbon to carbon chain that is incorporating that functional group of the parent structure, the parent's name. So the functional group is the ketone group, and then the longest carbon to carbon chain is 1, 2, 3, 4, 5, 6. But then if you look very well, you realize that we have a branch chain, and in identifying the longest carbon to carbon atoms in an organic molecule, we need to go to follow the branch chain, just so we can determine if the longest carbon to carbon chain is still part of the branch chain is still part of the longest carbon to carbon chain. So in this case, it's actually true. So this is 1, 2, 3, 4, 5, 6, 7. But if we just look at this way, it's going to be 6 carbon atoms. But if we look at it, including the branch chain, it's going to be 7 carbon atoms. And so that's why we have 1, 2, 3, 4, 5, 6, 7. But then identifying the longest carbon to carbon chain is not the only thing that we need to do when trying to assign the parent name. We also need to make sure that we follow the direction that gives us the lowest possible number for the substituents that are present in the molecule. So in this case, this is the parent structure. So this is the parent structure. So this becomes substituents, and since we are following this path, and this also becomes substituents. So the parent's name becomes 1, 2, 3, 4, 5, 6, 7. It becomes X. It's going to be an heptanone, basically. heptanone. But we are not just going to say heptanone. We have to include the position of the one. The one is the ketone group. We have to include the position of the one. And if you look at it this way, it's going to put our ketone on the second carbon atom. But if we go this way, it's going to put our ketone on the 6 carbon atoms. So we drop that direction. We're not going to follow a direction that's going to end up having ketone group on the 6 carbon atom when we can have it on the second carbon atom. So we follow this direction. Legit. Excuse me. So this is going to be the parent name for this molecule is going to be, okay, let me write it here. The parent name is going to be heptanone. Actually, heptanone, not heptanone. It's going to be heptanone. That is the parent name for this molecule. But then we have substituents. We have hydroxyl, we have methyl. So since we are following this direction, so this hydroxyl is going to be on the 1, 2, 3, 4, on the 4th carbon. And this methyl is going to be on the 5th carbon. But then we have 2 substituents, right? Hydroxyl. So we say that is 4 on the 4th carbon. And we say methyl is on the 5th carbon. But then how are we going to put these 2 substituents beside this parent name, parent structure? We are going to consider the first letter of the substituent. In this case, the first letter is H. In this case, the first letter is M. In the English alphabetical ordering, we have H before M. And so this is going to come first before this one. So that the name of this compound becomes 4-hydroxyl 5-methyl heptan 2-one. So that becomes the name of the compound. I mean, the name of the compound becomes that, whatever. So you have this as the name of the compound, and just like we have it in the IUPAC naming priority, we see ketone is taking priority in this molecule, and OH is becoming a substituent. It's no longer, this compound cannot be an alcohol. But if there was no ketone in this molecule, this compound would have easily become an alcohol. And also, if we have this kind of functional group in this molecule, let's say instead of a methyl group here, let's even say we have a carboxylic acid here. This molecule is not going to be a ketone again. It's going to be a carboxylic acid, because the carboxylic acid functional group has higher priority than the ketone group in the IUPAC naming convention. And so that is the brief on the nomenclature in organic chemistry. It's a big topic, but I've been able to only touch an aspect of it, and I do hope that you've learned something. And in the next class, we're going to consider another aspect of probably nomenclature, or we dive into a brand new topic in organic chemistry. And this is the end of the class, and I do hope you can subscribe to this channel and share the channel with your friends and loved ones. And I do hope to see you in the next lecture. Thanks and bye.